So there's a new AI model on the scene, and it is making some serious waves in the dev world. It's called IQuest-Coder, and trust me, this is not just another run-of-the-mill coding assistant. The performance we're seeing is so next level, it's forcing a huge conversation about the very future of how we build software. So let's dive in. Let's break down what this thing is, how it actually works, and why it's such a big deal.
You know, if you've been following the AI space for a while, this whole situation probably feels a little familiar. It's kind of like déjà vu, right? We saw something just like this with Deepseek, where this underdog model just pops up out of nowhere and starts going toe-to-toe with the industry giants. Well, it looks like IQuest-Coder is the next chapter in that same disruptive story.
And honestly, the stuff this thing can do, it's almost hard to wrap your head around. We're talking about an AI that can generate entire, fully functional applications from just a single text prompt. This is fundamentally pushing the boundaries of what we thought was even possible for AI in software development.
Okay, just take a look at this. This is an interactive Boyd's flocking simulation. It perfectly mimics that complex, emergent behavior you see in a flock of birds. All those intricate rules, separation, alignment, cohesion, the whole shebang was generated from one simple text command. And it runs instantly, right in the browser. It's just a stunning demonstration of raw creative power.
So how in the world does it do this? Well, it's not magic, even though it kind of feels like it. This remarkable performance really comes down to a core innovation in how the model is trained. There's a secret sauce here, and it unlocks a totally new kind of coding intelligence.
And that secret is a paradigm they're calling code flow training. Now, instead of just learning from static, finished code, this method trains the AI on the entire evolutionary history of a software project. It learns from every single commit, every change, every bug fix. So in essence, it's learning the process of creation, not just the final product.
This really illustrates the difference perfectly. Traditional models learn from a finished product. It's like looking at a static snapshot in time. But code flow training teaches the model the dynamic journey of how code actually evolves. It learns to understand context and patterns, not just isolated snippets of code. And that is a fundamental shift in how we teach an AI to code.
Now, this learning is then refined through a really sophisticated multi-stage pipeline. It kicks off with broad training on general code. Then it gets specifically trained on complex problem solving and how to act independently to achieve a goal. And finally, the model is split into two specialized versions, one that's designed for following instructions perfectly, and another one that's all about deep, creative thinking and complex reasoning.
This unique training method results in a model that absolutely punches far above its weight class. And the performance metrics and real-world capabilities, well, this is where the story gets truly remarkable.
As a practical example, IQuest-Coder was asked to generate a complete, playable Minesweeper game from a detailed prompt. And we're not talking about a simple script here. This is a full application in pure C using no external libraries. And the wild part? It compiled and ran perfectly on the first attempt, flawless.
And its skills aren't just limited to back-end logic either. The model also excels at front-end development. It can take a complex prompt and produce a really sophisticated interactive UI, like this cybersecurity operations dashboard. And that's a task that requires a deep understanding of both code and user-facing design.
And here are the numbers that are causing all the buzz. On the respected SWE-bench benchmark, IQuest-Coder's 40 billion parameter version scores an 81.4%. Now, to put that into perspective, that puts it in a statistical dead heat with Claude Opus 4.5, one of the most powerful proprietary models on the planet. But here's the truly staggering part. While it's matching Claude Opus in performance, IQuest-Coder is estimated to be 15 to 20 times smaller. Let that sink in for a second. This isn't just an improvement, it's a monumental leap in efficiency. We're talking about state-of-the-art results with just a fraction of the size. Now, when you have such extraordinary claims of performance and efficiency, they are, understandably, met with a healthy dose of skepticism from the research community. I mean, when something seems this good, you have to look closer, right? And the core of the controversy is really this. Are the results just too good? The concern is that the model might have been specifically overtuned to just crush this one particular public benchmark rather than having true, generalizable intelligence. So it opens up this serious discussion about bench gaming, which is the practice of optimizing a model just to get a high score on a test, which doesn't always translate to real-world capability. It's a major issue because it can create a distorted view of progress in the field, and the debate over IQuest-Coder's true generalized performance is still very much active.
But if we focus only on the benchmark debate, I think we risk missing the bigger picture.
The true takeaway from IQuest-Coder lies way beyond any single number.
So regardless of the final verdict on the benchmarks, IQuest-Coder's impact is pretty undeniable. It introduces a powerful new training paradigm, it demonstrates a whole new frontier of model efficiency, and it forces a critical conversation about how we even measure progress in AI in the first place.
Ultimately, the benchmark score is less important than what it signifies. The true breakthrough here is the method. Teaching an AI to understand the dynamic, evolving process of creation, not just the static final product. That seems to be the key to unlocking a new generation of profoundly more capable and efficient intelligence.